Okay, so experiment 1, we're talking about an assignment from a pharmaceutical company who have had a rival company claim that their preservative, sodium benzoate, chemically changes in people's stomachs to a different compound. So your job is to refute this claim that the sodium benzoate chemically changes in a human being's stomach. So you're going to have to recreate those acidic conditions of the stomach by taking the sodium benzoate and dissolving it in water and then adding 3 molarity hydrochloric acid until you get to a pH below 2. So what do we know about this pharmaceutical company's preservative? It's an organic compound, but it has formed a complex to a sodium ion. So the sodium benzoate does have some ionic character, which is going to make it soluble in water and insoluble in organics like dichloromethane. So what could the sodium benzoate chemically change into in a human stomach? Well, a conjugate partner to sodium benzoate is benzoic acid. The only difference between the two compounds is the presence or absence of a proton. Benzoic acid is truly organic, which means it shouldn't be soluble in water. So if we do get chemical change in your experiment today, there's a high likelihood that you'll form a solid precipitate of benzoic acid. Insoluble in water, it's soluble in organics like dichloromethane and diethyl ether. And benzoic acid itself, being the conjugate of sodium benzoate, it should be easy to see that sodium benzoate is part of a conjugate pair. And its conjugate partner is benzoic acid. We can flip between the two chemical compounds just by adding or removing a proton. In the case of the sodium benzoate, we can react it with a source of hydronium ions, like hydrochloric acid, when dissolved into water, and we get an acid-base reaction. The sodium benzoate acting like a base, and our hydronium ions are a source of acidity. So we get a proton transfer from the acid to the base. The benzoate picks up a proton, like any good base from the Bronsted-Lowry theory. The hydrogen to oxygen bond breaks, the electrons go to the oxygen, and we get that chemical change into benzoic acid, the conjugate form of sodium benzoate, and the conjugate form is itself an acid. It can give off a proton in a back reaction to reproduce the original sodium benzoate. So conjugate pairs are two compounds which only differ by the presence or absence of a proton. Now remember, once your chemical reaction is finished, if you do produce a precipitate, you'll need to filter off your liquid, the water, by using a Buchner funnel and flask. So connect up your Buchner flask to a clamp stand so it doesn't fall over. Put a piece of filter paper inside to neatly fit in the bottom of the funnel. Connect up to the vac line, turn on, and then filter your solution through. Any solid precipitate you formed will be retained in the filter funnel. Once you've drained off all of your solution, you can use a spatula to scrape any more material into the filter funnel, and then leave it under vacuum for perhaps 5 to 10 minutes to try and drain off as much water as possible. Now if you find it difficult to scrape the last of the solid out of your beaker, you can always remove the vacuum, switch off the vacuum source first of course, take out your beaker, then carefully taking off the boot and the funnel, careful not to spill any of your collected solid, you can pour the liquid which is filtered through back into a separate beaker and reclamp your boot and the flask. Set up your filtration again, switch on the vacuum once more, and then using some of that liquid which is filtered through, use it to stir around and gather up the last of the solid precipitate. So you're not increasing the volume of the solution any. Take the sample out of the oven after 5 minutes and recheck the mass of your sample. Once you get 2 measurements which match and show no loss of water, then your sample is completely dry. And don't forget that the benzoic acid can sublime above 90 degrees Celsius, so make sure the temperature of the oven is below 90. 80 or 85 degrees Celsius should be fine. So for your hypothesis, what could possibly happen to the sodium benzoate? Well, as we look at its structure, it should be clear that I can't remember what I'm going to say next. That's kind of bad, isn't it?